Hello and welcome to this video. We are going to solve the exercise, Exploiting Origin Server Normalization for Web Cache Deception. In the video description you will find a link to a write-up. The write-up contains more detailed descriptions. So if you have any questions, just have a look in the write-up. After we have started the exercise, the blog should look similar to this in the video. We click on the link, My Account, and log into the application with the username Wiener and the password Peter. After successfully logging in, we see the user account of Wiener and an API key. We now switch to the burp proxy and open the HTTP History tab. There we search for the request get/myaccount and send it to burp repeater. In the burp repeater, we change the first line of the request from get/myaccount to get/myaccount/abc. Now we send the request to the application and receive a 404 not found. We now change the path from get/myaccount/abc to get/myaccountApp. We receive another 404 not found. We send this request to burp intruder. We now switch to the burp intruder and adjust our request. We then click with the mouse between /myaccount and abc. Now we insert a payload position by clicking on the Add button. On the start page for the exercise there is a link to a list of limiters. The list is also in the write-up. In the subsection Payload Configuration, we paste the list of limiters we have just copied. In the subsection Payload Encoding, we deactivate the checkbox URL encode these characters. Click Start the attack. In the result window, we now click twice on the column Status Code and see that only the character ? Has received a 200 OK code. This indicates that the origin server only uses ? as a path delimiter. In the repeater, we now remove the character string ABC from the request and insert a directory with an attached coded point sequence /AAA/%2FMY account. We now send this request to the application and receive a response with our API key. This means that the origin server decodes and resolves the dot segment and interprets the URL path as /myaccount. Now we switch to the HTTP History tab in the burp proxy and see that static files all start with the prefix /resources. If we look at the responses to the requests, we see evidence of caching. We select a request, get/resources/js/tracking.js, and send it to burp repeater. In the repeater, we place our coded point sequence, %2f, between the prefix /resources and the resource, /js/tracking.js. When we send this request, we receive a 404 not found response, with the header xcache and the value miss. If we send the request to the application again within 30 seconds, the value of the header is hit. This may indicate that the cache is not decoding or resolving the point segment and has a cache rule based on the prefix /resources. We now append a random character string to the prefix /resources and send it to the application. Again, we receive a 404 not found response, with the header xcache and the value miss. If we send the request to the application again hit. This confirms that there is a static directory cache rule based on the prefix /resources. We now switch to the burp repeater and go to the tab that contains our request. Here we replace the character string AAA with the prefix /resources. When we send this request, we receive a 200 OK response with our API key. The value of the header xcache is miss. Send it again. The value changes to hit. Now we create our exploit in the exploit server. In the bodies section, we create an exploit that redirects the user Carlos to a malicious URL. Now we click the button, Deliver Exploit to Victim. Copy the URL from the exploit and paste it in a new browser tab. Now we see the API key of Carlos. We now copy the API key and click on the Submit Solution button. A window appears in which we paste the API key. We have successfully completed the exercise.